Let's study the topic on chemical bonding. To attain stability, we all know that atoms of element should form a doublet like helium or an octet like noble gases. To attain stability, atoms of elements tend to combine with each other. This takes place by the formation of chemical bond. A chemical bond may be defined as the force of attraction between any two atoms in a molecule to maintain stability. Chemical bonds are of three types: ionic bond, covalent bond, and coordinate bond. To attain stability, atoms of element have two options. They can either share electrons or transfer electrons. When there is transfer of electron, that is, the loss or the gain of electrons, the bond formed is ionic bond. Whereas when there is equally sharing of electrons, that is, both the atoms share equal number of electrons in the bonding, the bond formed is covalent bond. But when there is unequal share of electron, that is, both the electrons or a pair of electrons are being contributed by only one element or one atom of an element, there exists coordinate bond formation. Ionic bond is also called as electrovalent bond because of the presence of strong electrostatic force of attraction. The definition of ionic bond is the bond formed as a result of the transfer of electrons from one atom of an element to one atom of another element. The chemical compounds formed by the ionic bonding are called as electrovalent compounds. Conditions required for the formation of ionic bond. The first one is ionization potential. It refers to the energy required to remove an electron from the outermost orbit. In the formation of ionic bond, we all know that one atom loses electron whereas the other accepts it. So, the ionization potential of one atom should be lower so as it is capable of losing electron readily, whereas the ionization potential of the other atom should be higher. The second condition is electron affinity. It refers to the energy released when an atom gains an electron. In ionic bond formation, one atom should have lower electron affinity, whereas the other atom should have higher electron affinity so that it can accept electrons readily. The third condition is electronegativity. If difference in electronegativity is more between combining elements, then the bond formed is ionic bond. For example, electronegativity of sodium is 0.9 and that of chlorine is 3. We can see there is a huge difference in the electronegativity of the two atoms. So, when they combine to form a compound NaCl, the bond formed in between NaCl is ionic bond. Let's move on to the concept of electrovalency. Electrovalency is the number of electrons that an atom of an element loses or gains to form an electrovalent bond. Before moving on with the study of formation of ionic bond, you should first understand the difference between atoms and ions. Atoms are electrically neutral particles. They don't have any charge, whereas ions are electrically charged particles. They include the cations, which are positively charged, and the anions, which are negatively charged. Atoms may or may not exist independently, whereas ions exist independently in solutions. In atoms, the outermost shell may or may not have doublet or octet, whereas in ions, the outermost shell have complete doublet or octet. Example of atom is a neutral atom of sodium I am taking. In ions, I would refer to a cation of sodium. An ionic bond is formed between a metal and a non-metal. Metals lose electron to form cations which are electropositive in nature, whereas non-metals gain electron and forms anions which are electronegative in nature. For example, sodium, a neutral atom of sodium, when gives electron, it forms a cation. Similarly, chlorine, a neutral atom of chlorine, when takes up electron, it forms chlorine anion. As both are oppositely charged ion, they tend to attract each other. They come close together to combine and form a compound which is known as NaCl. Let's study a new concept, that is electron dot structure, which is also called as Lewis symbol. The electron dot structure for an atom consists of the symbol of the element surrounded by dots representing only the outermost shell electrons, that is the valence electrons. Over here, hydrogen is having only one electron in its outermost shell, which can be represented as this. The paired electrons are represented by a pair of dots, whereas the unpaired electrons in the outermost orbit is represented by a single dot. Example, aluminium is having 3 electrons in its outermost shell. So we will be representing aluminium as this. Similarly, we know that chlorine is having 7 electrons in its outermost shell. We would represent chlorine as per electron dot structure as this. The same goes ahead with magnesium and oxygen. Let's see how to represent the formation of NaCl with the help of electron dot structure. We know that sodium is having one valence electron, which is represented as this, and chlorine is having 7 valence electrons, represented as this. Now during this combination, sodium gives away one electron which is accepted by chlorine atom. The intermediate step is the formation of cation sodium and an anion of chlorine. The last step is the combination of these two ions, that is cations and anions, ultimately leading to the formation of NaCl compound. Similarly, we can show the formation of calcium oxide with the help of electron dot structure. Calcium is having 2 valence electrons which are denoted as this. Now, in order to trace from where the electrons are coming, it can be possible to represent electrons of different atom of an element as X or as a 0. Here I will be using X to represent electron from another atom. So oxygen, we all know, have 6 electrons in its outermost shell, which I will be representing as this. Now, calcium gives away these 2 electrons to oxygen. The intermediate step, which is the formation of cations and anions, is shown, after which there is the ultimate step of the formation of compound calcium oxide. At the end, you can clearly make out, due to the different symbol used, the electron which are being given by calcium. Similarly, we can show the formation of MgCl2 with the help of electron dot structure. Magnesium with its 2 valence electron is represented as this. Plus, there are 2 atoms of chlorine involved in this particular reaction. Now, magnesium gives 1 electron to each chlorine atom, thereby forming an intermediate step of the formation of cation magnesium and 2 anion of chlorine, thereby leading to the formation of MgCl2. Redox reaction. A reaction in which reduction and oxidation takes place simultaneously is called as redox reaction. Oxidation is loss of electron. So, in a reacting system, if an atom A loses an electron to form a cation, there should be another element who should be ready to take up this lost electron. In this example, we have an atom B of another element who is accepting this electron. Here, B is acting as an oxidizing agent, which helps in the process of oxidation by gaining the lost electron. Now, reduction is gain of electron. If an atom B gains an electron to form an anion, there should be some atom who should be ready to give up electron so that it is acceptable by atom B. In this example, we are having another atom A which is giving up electron to the atom B in the process of reduction. Over here, the atom A is the reducing agent, which is helping in the process of reduction by giving up or by losing electron, which is gained by atom B. Thus, a redox reaction is a combination of oxidation and reduction with the presence of reducing agent as well as oxidizing agent. Let us study the concept of redox reaction with one of our familiar equation, that is the formation of NaCl. Here I am having 2 atoms of sodium combining with 1 chlorine molecule to form 2 molecules of NaCl. In formation of NaCl, there is loss of electron and gain of electron. Loss of electron, that is oxidation, is taking place when sodium gives away 1 electron to form sodium cation. But In the equation, we can see there are 2 atoms of sodium involved. So, multiplying this oxidation equation throughout by 2, we get this. Now, taking the 2 electron to the other side of the arrow, we get the equation to be as this. Now, in the reduction process, we have chlorine taking up 1 electron to form chlorine anion. In the main equation, we can see 2 atoms of chlorine combining to form 1 molecule of chlorine which is involved in this reaction. So, for making these 2 atoms of chlorine into an octet, we require 2 electrons. Okay, so the second equation is Cl2 plus 2 electrons will give me 2 chlorine anion. These 2 equations are called as half reactions. Now, let's combine these 2 half reactions. On combining these 2 half reaction, we cancel out the 2 electrons from either side of this arrow and then add it up. We get the final equation to be as 2 sodium atoms plus 1 chlorine molecule will give me 2 sodium cation and 2 chlorine anion. This is the ionic form of the redox reaction.